This question is from the 2016 higher level DCG paper, section C. It's the Geologic Geometry question. Question C1. Part A. The accompanying map located on the back page of section A shows the plan of a garden with a swimming pool, similar to that in the image on the right. The ground contours are at 1 meter vertical intervals. Now they highlighted 1 meter there, they put it in bold. That is a little bit different to the questions we were doing all the other years now, because usually everything's at a scale of 1 is to 1,000, which means 1 millimeter represents 1 meter. Here it's a little bit different now. On the map, ABCD is the edge of the pool and is level at an altitude of 5 meters. Using side slopes of 1 in 1 for both the cuttings and the embankments, show the earthworks necessary to accommodate the eastern side of the pool. Okay, note the earthworks between A and B have already been completed for you. So they did a little bit at the top there just to show you the scale of what's going on, give you a bit of an idea of where we're going from there. Now, the center point is 0, so we're told that there's 1 meter between each one here. So usually it would be 1 multiplied by 1, because it's 1 in 1 for both cutting and fill. So 1 multiplied by 1 would give us 1. Now, because it's scale 1 is to 100, that means it's 10 times bigger than scale 1 is to 1,000. So therefore it's 1 multiplied by 10. So the spaces between each one of these now will be 10 as opposed to 1, because the scale is 1 is to 100. So I'm going to draw a line out from 0. I'm going to plot 10 between each one here. So 10, 10 and 10. 3 should be enough. Set your compass from the center and draw the arc. Distances here, the one at the side they tell us is level at an altitude of 5, so this line here must be 5 meters above sea level. And going out from it then, are we cutting or filling? If that's 5, they're all below 5 for a filling, so therefore that's 4, 3 and 2. So it starts off at 5, then it moves to 4, out to 3, and then 2. Back to 2 again, 3, 4 and 5. And you'll notice that the scale looks similar to this one here, which means things must be right there. So a lot of people made the mistake, it couldn't be 1 millimeter between each one, that'd be way too small, but the scale is 1 is to 100, means it's 10 times bigger than what we usually do. Bottom bit down here then, there's no sloped parts or anything like that. This one we are cutting, it's the same intervals for cutting, 1 in 1, so it's 10 between each one here as well. Again, it starts at 5, and this time we're going up 6, 7, 8, and 9. 5 starts there, next one then is 6, 7, 8, and 9. Back round to 9, 8, 7, 6, and 5 joins back to D there. Okay, that's the first part of the question there complete. Part B. DE is the edge of a sloping pathway. At D the pathway is at an altitude of 5 meters. So at D there it's at 5. And falls uniformly to an altitude of 4 meters at E. So that one there's at 4. Using the same side slopes as above, show the earthworks cutting necessary to accommodate the northern edge of the pathway. So they even tell you here that it's cutting and not fill or embankment. Now, cutting is 1 is to 1, so the intervals again will be 10. The difference in altitude here is 1, So if we were doing a normal question 1 is to 1,000, that'd be 1 multiplied by 1, which gives you 1. We need to scale it up then by 10, so the radius will be 10 here. Now we're told we're cutting, so it's cut at the foot, fillet the hill, cut. The foot is the lowest point, E, so we're going to be doing a radius 10 down here at E at the bottom. So set your compass to 10. Draw in your semicircle at E. And then the lines will be tangent from D to that semicircle. And the first one has to be 5 because it touches 5 there. Then we're going to work parallel to that at 10 millimeters between each one. It starts at 5, so then it goes up, so 5 there, 6, 7, 8 and 9. Now 5 is there, 6 would be that point, 7, I need to continue out, would be that one, 8 and 9, and then it comes back round itself again, 9, 8, 7 and 6. Okay, that's that part of the question finished, the sloping part. That's part B. Part C now, at the southern end, the floor slab of the pool is sloping and is of uniform thickness. R and S are 2 points on the floor and their altitude are 4 meters and 3 meters respectively. So R here is at 4 meters, S is at 3 meters. A vertical borehole at S reveals the bottom surface of the pool floor slab at an altitude of 1.5 meters. The strike of the floor is north 55 degrees east as indicated by the line L. So we're given the strike line there. Determine the dip and the thickness of the floor slab. Okay, dip and thickness. So we need to take our auxiliary view now along the strike line. Okay, continue on with L. There at the top. X1, Y1 perpendicular to it. Now we're going to need S in it as well. So that's X1 and Y1, and we're going to bring up R and S. So R is already brought up because that's in the strike line. S, you can bring it up there as well. Now, we were told that R is a height of 4 meters, so I'm going to measure up 40 millimeters there, because 1 meter equals 10, 1 meter equals 10 millimeters of this drawn. So that's R. S, we were told, goes up 30. So but that is S, so that's the angle now if we look along the strike line. That's the slope of the floor to the horizontal. What exactly are we asked for there? Vertical borehole at S reveals the bottom surface of the pool floor slab at an altitude of 1.5 meters. So if we measure straight down from S now, because it was drilled straight down, 1.5 meters, that gives me that point there. And if we draw a parallel line now to RS through that point, that's the thickness of the floor slab. So determine the dip and the thickness of the floor slab. That angle there now is the dip, same as usual, and the thickness is the perpendicular distance between those two lines, those two parallel lines. What's it say? Thickness. Okay, and that's part C of the question finished. Part D of the question then, there are 4 entrance steps to the pool as shown. The top step is level at an altitude of 4.8. Top step, okay, so that one there is 4.8. In the space provided, draw the vertical section profile through the steps and the floor slab along the line PS. Okay, so PS goes the whole way along there. Show the steps to be of equal height. Note the top step PQ has already been drawn for you. It is represented by P1, Q1 in the section view above. Okay, so first thing I'm going to do is draw that line across. PQ. Now we're told that R is at an altitude of 4. That's the very bottom of the step. And S is at an altitude of 3. So, with that in mind, 4 is going to be there, so I need to find an altitude of 4. Now, if that is 4.8 there at the top, I'm going to mark that. I'm going to measure down 48. So that's kind of like my ground line now, at the bottom there. You could call it an X1, Y1 if you wanted to. That's the ground. Now, the altitude there is 4. So I'm going to mark up 4. That's 4 meters above sea level, and that's point R. So the distance we're left with now, we know that there's 3 steps. I can bring up each one of the steps there one by one. There are 3 steps, and the altitude difference is 0.8. So we'll need to divide your 0.8 by 3, which works out at 0.27. Let me see, is there a graphical way of doing that? No. 3, 4. Technically, if you've 3 steps, you've 1 rise, 2 rise, 3 rise, and 4 rise. So technically there's 4 risers here and 3 horizontal. So the 0.8 will be divided by 4 instead of 3 to get us down to this. So divided by 4, that's 0.2 between each one. And it's getting to quite a small measurement. 2, 6, and 8. That gives you the steps there, and then if you fill them in, it's 4 vertical spaces and 3 steps. So technically, if we were to slice down through the steps there, that's the top step at 4.8, and it steps down 0.2 then till you get to R, which is at 4 meters. We're told that S then is at 3 meters, so I'm going to measure up 30 millimeters there, and then draw the slope going down. Okay, so that's the top portion of it there. Then we're asked in the question, show the steps of equal height through the steps and the floor slab. So we know that the thickness of the floor slab now is that thickness there, which is about 14. So if we measure now again, you can measure down your 15 straight from S, so we'll give you the same answer. Works out about perpendicular distance as 14. If you measure down 15 there and 15 at the top, should give you the same answer. Okay, so that's a full section view now. If we were to slice down along the line PS, that's the shape there that we'd see. And that's your full question complete.